Welcome to part 8, Choropleth Maps. So I've just completed the graph on the top right of the dashboard, which shows the deaths and cases for the actual and predicted values for every single area. Now we're going to create the map that will go on the bottom right of the dashboard, where the color of each country will correspond to some number like deaths or cases. So the type of plot we're going to use is called a choropleth plot. So in general, a choropleth plot is just some number of polygons where each polygon is colored based on the value of a different numeric variable. So in this case, our polygons are countries and US states. So the way to create a choropleth map in Plotly is to call this add choropleth method, and that's what we're going to do below. So at first, we're going to do one for the world and then another one for the USA. So the add choropleth method by default creates a map of the world without any coloring whatsoever. So we haven't given it what locations to color, but that's just your default display. Now to color it, what we're going to do is we have to give it some data. And so we're going to use this, the world data at first. And whenever we created this summary table, so this is the current dates data, number one. So we're not using all of the data. We're just going to look at the current day's data. So every country has a 3-letter code that is standardized and that Plotly understands. So what we're going to do is for the locations, we're going to grab or select this column as a series, and then the value of some numeric column, doesn't matter which one. In this case, we're just going to use deaths for the coloring. Now that will be assigned to variable z. So you can think of it as like x, y, and the z-axis is sort of the color axis. Okay, so now when you call add choropleth, what you can do is you give it the locations. In this case, it's just a series of these 3-letter codes, the values, and then the values for those locations, which will be parameter z. So those are the number of deaths. Then you give it, you can give it a minimum z, so it knows like, all right, what is the lowest part of the scale going to start at? So you can set this at anything. Here we set it at 0. Now we're also going to give it some color scale, and it's going to be a sequential color scale. And we can go to the part of the documentation that has these sequential color sequences. So a sequential color sequence is one that very slowly goes from one color to another. And these are what are needed whenever you're graphing some numeric variable where that has meaning in the order of the value. So smaller numbers mean that they are lesser than numbers that are bigger. So there's many different sequential color scales you can use. For this one, I'm using the orange to red over here. So it starts over here at this light orange, and then it gets at the highest is this darker red. So that's set over here, and then we're just going to set the margin. Let's go ahead and look at this. We need to execute this cell first. So now it takes every location and then the z value for that location, and it will color it in with the highest value, and the USA has the most deaths. So that'll be at the very top end of the color scale. So the country with the most deaths in this case will be the darkest, or be, I should just say, at the top end of this orange-red color scale. So you can see other countries that are closer to the top, like Brazil and India, but no country is that close to the USA, so that's why it's the only one that appears red. There are countries in Europe that are sort of towards the middle, but since the USA dominates so much because it has the most deaths, the other ones will look they'll appear quite a bit lower. So the total number of deaths is not the best metric here. We could change this to deaths per million to get maybe a little bit more of a gradient for all the countries. Okay, so what we're going to do now is change some properties of this choropleth so we can make it look a little bit nicer. There's different projections, like different map projections that are possible. There's actually many different map projections. And if we go to the documentation, you can see that there are quite a few different projections here. We're going to use one of them called the Robinson projection, and you'll see it in a little bit. So to set the projection, you use this geo parameter in update layout. We're going to remove the outside frame, and then what we're going to do is we're going to limit the latitude and longitude, so it's not necessary to see like Antarctica or very far north, and possibly cut off some of the some of the map on the west and the east, or really I should just say left and right. So let's go ahead and look at this. So it's a different projection. And you can see the Robinson projection has it. You can sort of see that it's kind of turning and looks more like, has a natural curve like the Earth. Setting the range of the latitude and longitude helps us zoom in on the area of the globe where there are, populated countries. And then, yes. So that makes it look a little bit nicer. Now let's move on down. We're going to look at this customizing the hover text. So right now, when we look at the hover text, we are getting the 3-letter ISO code that is standardized, along with the number of deaths. But we can customize this, and the way we do this is by creating a series. Just like we selected a series for the number of deaths, we can have a series that's has the same length as the number of areas, but has a very specific text. So what we're going to do is we're going to iterate through the df world data frame. So for every country, what we're going to do is we're going to just create this string. We're going to put the name, the actual name, not just the 3-letter code. We're going to put the current deaths, the current cases, the deaths per million, the cases per million, and the population. So we're going to put a lot of information in the little hover that will pop up whenever we hover our mouse over the particular country. So we're going to call this apply method in pandas, and this will go row by row and apply this function, which I just created over here, and it's simply just creating a string out of the data. So it's called text, and so here there's a string for each one. So now when we go down here, we're going to, again, we're just going to recreate the graph from start. So we're going to give it the locations, the Z, but importantly, we're going to give it this text series for the text. And you have to also say, set this hover info parameter to text. So it says, hey, look at this text and put this as the hover information. Let's go ahead and run this. So the graph is going to look the exact same. I kind of shortened it up here a little bit, but so now when we hover, we see that, okay, we get all this information popping up. So we get a lot more information to the users. And no longer just the 3-letter code, we get the actual name of every country. So it just makes it a lot nicer. It's actually also made it bold for the country name. So that's what you can do to change the hover text. All right, so that's our map for the world. Now we're going to do the same thing for the USA. It needs a little bit different inputs. So here you have to set location mode to USA-states. Otherwise, we're just going to do pretty much the same thing. We're going to get the code, which in this case is a 2-letter code for each state. And by setting the location mode, Plotly will understand that. We're going to get the new text, so just from the states now. And we're, obviously need to create the states data frame. And then the projection will be a special type of projection called Albers USA, and that just moves Alaska and Hawaii down closer to the rest of the 48 states. Okay, and we don't need to, limit the X or Y direction because it just happens naturally just for the USA state. So let's go ahead and run this. And here we did cases per million for Z. So this should give us a more even distribution. And the same thing when we hover over them. So it's pretty cool. We get all this information on the hover. North Dakota is at the top in terms of cases per million. So they're up here above 60,000. And since the states are a little bit more homogeneous than the rest of the world, you'll have a lot more diversification in terms of on the color map itself, or on the color scale itself. Okay, so so that does it for creating the Choropleth maps for both the world and USA. Very nice tool that Plotly has to create these interactive graphs and without too much work.